Yep. So I'll try to keep this as quick as I can. I went ahead and scripted this out this time. I felt like I was doing a little too much freestyling earlier today, so I'm going to stick to my script, if you will. So today is 10/24. And we are simplifying square roots. There is zero chance that you've made it to this point in your education and no one has taught you this. Like I know we do it in Algebra 1, so I know if you came through my class, I know you got it. Simplifying a square root is kind of like reducing a fraction. It doesn't change the value of an answer, it just makes it mathematically acceptable. So we math people agree, if you come up with an answer to an equation and you get 4/6, you're not allowed to leave it that way. We all agree you have to reduce it to 2/3. Radicals work the same way. And so for every radical or square root, there's a better version of that, and we expect you to come up with that. Okay, so we can't all have like different answers, like, oh, you got the square root of 40. Good. Oh, you got root 2 times root 20. Like there is an answer just like there is with fractions. So you guys all know what square roots are. So let's run through the list of numbers that are significant. And I'm going to start writing them up here. And I will, as I always do, run out of space. And you'll remember these numbers, if not immediately, very quickly. Do you remember the significance of these red numbers? They're squares. I could not have said that better myself. Thank you. They're squares. By definition, they are perfectly square rootable numbers. And there's obviously infinitely many of them. We tend to go to a certain point and then cap it off. That's not to say that there are more. It's just that there's a certain like sweet area where we want you to memorize a bunch. And then after that, you just kind of go, who knows? So anyways, let's keep going. Who's after 25? After 36? After 49? After 64? After 81? 100. Let's pause here in case anyone's like, what is happening? What is with these wizards? How are they doing this? We're just generating this by squaring numbers, squaring whole numbers. So I can write down below these what's happening. So like 1 squared made 1, right? 2 squared made 4. 3 squared made 9. 4 squared made 16. 5 squared. And another way to say that is if I say 5 squared equals 25, conversely, then I can say that the square root of 25 is 5. And of course, 36 produces a 6, 49 produces a 7, 64 goes with 8, 81 goes with 9, and 100 goes with 10. So we don't stop here, though. We want to keep going to a certain point where it feels like, okay, we're getting a little out of control here. What's after 100? 121 after 121. Yeah, I really need you to speak up because the air conditioner's on. That was no louder at all. But thank you for the sentiment. I appreciate it. After 144? Yep, 169. After 169? Thank you. 196. After 196? Nice job. You might be looking at a resource that I actually gave you months ago. Wow, it's weird that we're far enough into the year that I can say that now. Like a couple months ago, I gave you a piece of paper that had, do you remember all the roots and stuff on it? So you have a piece of paper that has these. So we want to kind of be a little more quick draw though. Like we want this red list to always be just kind of right across in our brains. So good job if you're using your resources and just reading these to me, because that's dope. What's after 225? Oh, thank you, air conditioner, for some peace and quiet. So the next one is 256. Anyone know after 256? Nice job, 289. And I always have to go down the side of my page. I've taught this lesson probably 80 times, and I've never once had enough room across the screen. What's after 289? Let's fill in some while you do your math, whatever you're up to. So 121 square rooted makes 11. 144 square rooted makes 12. 169 makes 13. 196 is 14. 225 goes with 15, 256 goes with 16, and 289 is square rooted to make 17. Anyone know 18 squared? Is 324. And at this point, I'm going to have to start working down the side of the board. I don't have a lot to go, but I just can't fit them all in. 324, of course, square rooted becomes 18. And that leaves us with just a couple more. Anyone know what's after 324? No, there's one in between, actually. 400 would take us all the way to 20. Yeah, 361 is the next one on the list. So 361 is a red number. It's on the red list because it's square rootable, and his square root is 19. And 400 is, of course, the last one. Student sent me an email earlier. I walked over to a kid's desk, and he had on his Chromebook, he had Googled a table that had all the first squares, and his table was pretty rad. It went up to 625. So if I can find a nice presentable way to get that to you, I will, and hand it out to you just like I did the other things, so you can have a resource. I have no issues with you looking at a resource, but I do think at some point you will agree, if you take time to actually memorize some of these, you will just enjoy the process more. It feels less kind of sluggy if you're able to recall things. So that's where I stop always. But there are more, like you could do 21 as 441 and so on and so forth. But this is a sweet spot. So the idea today is we want to just practice the fine art of breaking down square roots. And so listen, if I gave you the square root of 9, I wouldn't ask you to quote unquote simplify it. What I would ask you to do is evaluate it. Because like I can give you a regular answer for this, can't I? What is the square root of 9? That is 3. So that's not the focus today. Like I'm not going to just quiz you on what's the square root of 9, what's the square root of 100. The idea today is, what do I do when someone asks me to find the square root of something that's not up on the board in red? And I hope you remember this as we start to work this. So let's say, for example, that I gave you the square root of 27. You know right away 27 himself is not a square. But then the hunt is, how can I break him up so that he has two factors, one of which is a square and one of which is not? No decimal. I know what you're talking about, and that's probably more of a Mr. Manlove from geometry thing, where he wants you to know like that the square root of 5 is somewhere between like 2 and 3. I'm guessing that's something you would have done like with line segments. But for us, I'm not interested. Listen, we all know this is 5 point something. I hope. Like it's bigger than the square root of 25, right? And that would have been 5. So we know it's 5 point something. So, but I'm not asking you to approximate. That would be called an approximation. I'm asking you to simplify. And so what we do is, I've got a couple ways, and I'm actually going to start using something other than the tree a little bit more. I think I've decided I like it. But one way you'll remember I taught you a long time ago is to make a tree. And at the end of the tree branches, make sure you always just put 2 blank square root signs. There's always going to be this 10% of kids who don't think they need to put the square root signs, and they're always going to be the same kids that say that the square root of 24 is 4 root 6. So you have a choice to make. Like, do I want to draw the blank square roots, trust this man, or do I want to just go rogue? That's your call. The square root signs will help you to avoid very particular pitfalls. So when I take the square root of 27 and I break it into 2 square roots, I want to choose wisely. I want to choose 9, and then I want to choose 3. And the reason I chose 9 is because it's useful. What is the square root of 9? It is 3. And so the simplified version of the square root of 27 is 3 root 3. That's how we say that. Now, another way to do this, and like I said, I found myself today using this one actually more than the tree. And I think it might be because I know where we're headed. Like eventually we're going to be simplifying like the square root of 132 j cubed m squared r to the 11th. And when we do stuff like that, having a less tree kind of thing and a more horizontally thing you'll see is beneficial. So another way to do the square root of 27 is to take and break it up just without the 2 separated radicals, but just do 1 radical and then break up the inside into something square rootable and something not. It's a cleaner method, right? And but the same thinking is that, okay, the square root of 9 is 3, so I pull that out and I just, look, I still get the same thing. 3 root 3. So you'll hear me refer to this guy. I'm going to point to him with yellow arrows. When you hear me use this term, I refer to him as a jailbreak because it becomes to me a real logical thing. It starts to feel like it makes sense that 9 said, hey, I'm busting out, and he broke out and became a free man, whereas the 3 is still stuck in prison. So if you hear me say jailbreak, I'm referring to the things that get popped out of the root. Okay, so you pick, but again, I am up here with the fake pen and more likely going to be using the horizontal method today and beyond. So all right, let me rapid fire some at you here and let's see how we do. Square root of 8. What would I break 8 up into? Yeah, and I'm going to stop switching colors because it takes time. I don't have options with 8. If 4 and 2 doesn't work, then it's not a simplifiable radical. But 4 is progress. What's the square root of 4? So we would say the answer to this is 2 root 2. You don't need to say 2 times the square root of 2. Just a quick 3-word answer. 2 root 2, done. Okay, next one I have for you is the square root of 200. And really, you just want to always have that red list handy, whether it's in your head or in front of you on your desk. And you want to go through the red list and don't stop when you find the first thing that works. Because if you're a left to right person, the first one you're going to find is 4 times 50. Because 4 is on the red list, right? But the trouble is that you don't want to leave meat on the bone. You don't want to leave the square root of 50 because then he contains more squares. So keep going through, on. What is the biggest red list number that goes into 200? What is the biggest number on the red list that goes into 200? 100. Good. And I know your heart was in the right place, but you should always try to answer the question for like where we're at as a class. So you see, I went as deep as I could. I found the biggest possible red number. And what is the square root of 100? 10. So we get 10 root 2. How about this one? You have some options with 24. What would be wrong if I chose this? If I went up here and I did this? Like, I don't understand, Mr. Ahern. What's wrong with that? What's wrong with 3 times 8? Yeah, neither of them do me any good. So don't go wasting your time breaking it into numbers that aren't rootable. Like in the context, we're doing square roots. I need squares. So what am I looking for 24? Not 2 times 12. That won't do me any good. What's the magic for 24? There it is, 4 times 6. And the square root of 4 is 2. So my final answer is 2 root 6. And sometimes people say, wait, can't you break down the square root of 6? I'm not asking you for prime numbers here. Like we're not going for prime. Yes, I get that 6 can be broken down, but his factors are all garbage, right? 2 and 3 are garbage, so 6 is we call that a dead root. Okay, how about this one? So I'm assuming you have calculators. It's like October 24th, so by now I'm sure you've taken the time to acquire one. And this is where you really want to start utilizing your resources. So do you notice anything about the square root of 324? I liked, oh, that did not take as long as I thought it would. I thought I could convince you guys to mook around with combinations. Annie very much saved the day. What is the square root of 324? So sometimes you're actually going to get a number and you think like, is someone toying with me here? Don't go making a tree or whatever on a number that doesn't need it, right? That's the key. So good job. You caught my little trick there. So any questions about generally just how to do this? Okay, so I have a couple more sections specifically that I wanted to talk to you about. The next one, you'll remember this from last year specifically, or maybe even a couple of years ago. As Sutter pointed out, these are death numbers. And I call them that. That sounds like awfully dramatic, but I call them this because they're the ones in my years that I found kids lose the most points on. And I'll explain to you why that is as we work. But I'm giving you this. This is a gift from me to you. I'm going to give you 1, 2, 3, 4, 5, 6, 7 numbers. And that's not all. Let's add death numbers as we find them. If you get to one where you're like, oh man, that one kicked my butt, add it onto your notes as a death number. The first death number, believe it or not, looks so innocent, and it's not. The square root of 32. If I had $1 for every point I've taken off for this, I could probably pay off my house. What's everyone's first thought on 32? Normal people. What'd your fourth grade teacher get paid to get stuck in your head? 4 times 8, right? If you don't know your times tables, then this is like a foreign language to you. But everyone who knows their times tables should immediately think 4 times 8. That's what Mrs. Schlockendorker in fourth grade taught me. It was 4 times 8 is 32. What's the problem with 4 times 8? They're not both squares. It can still be worked more. And so if I go this route, if I do 4 times 8, I'm like, I know my times tables. Like the square root of 4 is 2. Here's my answer. Like, what's your beef? You put this into Delta Math wrong. Sorry, your answer is incorrect. What? What did I do wrong? Well, what you did wrong is you left meat on the bone. What can the square root of 8 then subsequently be broken into? Another 4 and 2. So if I go again now, you see I'm making something that should take 1 step, take like 3 or 4 steps because of a poor choice from the onset. And I can still get there. I can still take, what's the square root of that 4 that I just circled? 2. And when I jailbreak out that 2 and it multiplies by this other 2, I get 4 root 2. But I heard someone say it completely like not good timing. You didn't answer any question I was asking, but you're right. You're totally right. The square root of 32 for your notes should always be done as 16 times 2. And the reason this and the next ones you're going to see are death numbers is because assuming everyone in your education to this point has done their job, your parents, your elementary school teachers, and you know your times tables up through what number? Where does your times table stop? 12. That is the normal. You go anywhere, go to Vermont, go to Florida, go to Oregon, go to Southern California. You pull up a times table in any math classroom, and it's going to go to 12. It's just a thing. We go to 12 times 12 is 144. And then after that, we're like, good luck, kid. 12 times 13. If you get a kid who knows their times tables, you ask them 12 times 11, they know it. 12 times 12, they know it. 12 times 13, and they go, I don't know. And that's because of where we stop. And that's why 16 times 2 is a death trap, because we don't think in those terms. So when you see 32, do root 16 times 2, which much more quickly arrives us at 4 root 2. Got it? All right, the next death number I have is 48. And again, it's not your fault. You think of 2 things. You should think of 2 things. Number 1, 6 times 8. Why is 6 times 8 garbage? They're both trash. Neither one of them is any good. 6 and 8, you can't square root of 6. You can't square. Why would you pick 2 numbers where you can't make any progress at all? What's wrong with 4 times 12? 12 has meat on the bone. So you got to go deeper, deeper, deeper. What's the magic combo for 48? It is. So for your notes, and you can add this on to like even that piece of paper I gave you that had all the roots on it. You can add a little section on that you just always have like for your death numbers, right? And 48 is always going to be 16 times 3, which is 4 root 3. And as Seth pointed out earlier today, he said, I think I'm quoting directly, I think I see a theme here. The next death number is correlated again. It's the square root of 80. You think of 8 times 10, garbage. You think of 4 times 20, no good. What's the magic? Who thinks of this? Well, you will after this. What works for 80? That's it. We don't think of 80 as 16 times 5. We think of them as 2 times 40 and 4 times 20 and 8 times 10. We just don't think of it like this, but we know now that that's the quickest route from point A to point B. You see the theme, obviously. The demon number here is 16. 16s suck because we don't learn 16s in elementary school. We go up through 12 and then we peace out. So the last one that involves the number, actually I have 2 more that involve the number 16. When you see these, you know what to do. You're powerful, you're armed and dangerous. Square root of 96 is, take a shot, take a guess. Keep with the theme. 16 times 6. So now we know that the square root of 96, you don't have to take some big circuitous route to get to it. You go right after it, attack it, aggressive. 16 and 6 leaves us with 4 root 6. And the last one that I thought I'd throw at you is 112, because you could stare at that number for a long time. You want to take a shot? 16 times 7. So this one becomes 4 root 7. You've been warned, okay? Those death numbers are nasty. They're going to contain 16s. I also have some death numbers that contain another guy. And the first of these, I'll draw a little line here, is the square root of 72. Again, I say this, someone got paid to teach you that 72 is 9 times 8. It should be so stuck in your head that when someone says 9 times 8, you're saying 72 before they can say that part of 8, right? It's just ingrained in you. What's wrong with 9 times 8? It can go further. 9 is good. Yay, but 8 has meat on the bone. What's the magic combo for 72? Just trying to make you better mathematicians here, make you quicker, more fluent with the language. What's 72? That's what it is. Who'd have thunk it? 36 times 2. What a gorgeous combination. What's the square root of 36? So our answer is 6 root 2. How about the square root of 108? And please, I encourage you, add to these. Be proactive. When you find a number that kicks your butt, add it to your list. And then you always have it on that one-stop shop piece of paper with all the powers and roots and stuff. Add death numbers. Make a little corner. Anyone know what 108 is? It is 36 times 3. Again, who'da thunk? So 6 roots of 3. And we could go on and on, but those are the ones I find to be the most commonly butchered. And then finally, just a pro tip for you before we get to the imaginary numbers. If you get big numbers like this, what I like to do, here's a trick for you, is I like to divide by small numbers. Because if you take a big number and divide it by a really small number, your answer is still pretty big, right? So normally I would say, why would you be dividing by 2? Why are you dividing by 3? Like 2 and 3 are trash. In a case like this, it's not about what we're dividing by, but it's about what gets left over, like from the carnage. So what do you obviously know you can divide 288 by? 2. Does anyone know what you have to multiply 2 by to make 288? What's half of 288? And look at that. So I wasn't interested in the 2. I never was. I was interested in what he would leave behind. And when you divide by 2, you're like, whoa, you popped me out a huge square rootable number. Thank you very much. So the answer to that one would be 12 root 2. Done. You could stare at that for a long time. How about this one? Again, you're not interested in 2s and 3s and 5s, but dividing by them can produce gorgeous results. This one obviously cannot be divided by 2, duh, because it's odd. Try dividing him by 3. What do you get? Bless you. You do. What a gorgeous thing to realize. I just made 121 times 3. Bless you again. And again, I'm not interested in the 3, but I sure am interested in that huge chunk of a number, 121, whose square root is 11. Here's another big one for you, the square root of 648. Screw around with it. And this one, you probably don't need a calculator, but if you do, I'm not going to like make fun of you. Again, use the trick. When numbers get big, rather than scouring your red list and trying, can I divide it by this and this and this, just go take that back kind of route and say, maybe I can find what I'm looking for more indirectly. Bam. And so I think to myself, how cool is this? If I actually take that back route, I can discover that if I multiply 324 by 2, I get 648. And why am I so interested in 324 times 2? Because 324 is on the red list. Jackpot. And his square root is 18, so 18 root 2. And I'm just telling you from experience, you can stare at a problem like that for several minutes, getting frustrated until you're like, oh God, that took me forever. Don't make it take forever. Start the little trick, divide by baby numbers, and hope that what pops out is a big number. So, pro tip. All right, the last part of this should not take long. It's hard to believe I want to do this in like 3 minutes, but I am going to try. So do you guys know what the problem is with this? I'm starting to wonder if I should stop avoiding this in Algebra 1, because the first day that it pops up like today, you look at it and you may not know how massive this is. But are you all aware of why that is impossible? Why is it impossible? Just because it's negative. Right. I mean, if you understand the definition of a square root, you understand that by definition, when I write that down, I'm saying I need you to multiply me a number by himself that will equal -4. And if you know some basic stuff, you know that that ain't happening. Because if you take -2 times himself, you get 4. If you take 2 times, you're like, crap, how am I ever going to make a -4? This officially now forces us to crack open this door that opens up this entire other half of a world of mathematics called imaginary numbers. I know that sounds hokey and corny, but these are going to be tied to the places where a polynomial function has a zero but isn't actually touching the x-axis in any way. These are imaginary. And so the way you fix this is super easy. You have to understand one little piece of the puzzle, and it's this. There's this little guy named I. Bless you, he's a lowercase I. And he is the foundational building block. He is the fundamental unit of that entire half of the number system called the imaginaries. And he introduces himself to you and says, hi, I'm I. I am equal to the square root of -1. He says, I open all these doors for you. I make that entire half of the world of mathematics workable for you. So we're now in a new number system called the imaginary system. Some people call it like a complex number system. It gets a little blurry. But anyways, here's the magic of why this works. I can take the square root of -4 and I can rewrite it up here as the square root of -1 times 4. I just broke the innards into my imaginary unit and my good part, right? And what is the square root of 4? So my answer is 2i. The 2 came from the square root of 4, and the I comes from the fact that, hey, this was imaginary. I had an imaginary unit that was built in there. In about 3 minutes, you're going to have this realization. If you haven't already, you're going to go, wait, are we just doing the exact same thing, except we have to stick an I in there? Yeah. How about this one? Right away, red flag goes up, and you say, you want me to square root a negative number? You better I need to know how to break this down. My first thought is it's imaginary. My answer is going to have an I, right? So what I'm going to do now, instead of breaking the guts into 2 pieces, I'm going to break it up into 3. And instinctively, the very first one I'm going to put in there is -1. I need to pop that imaginary unit out, get it out. And then how would you break down the number 44? We're back in the real numbers now because we got our -1 out. So what makes 44 that we care about? Are you stumped by my question, or is this just this fifth hour thing? Can you guys give me 2 numbers that multiply to make 44 where one of them is on the red list? That's what I'm looking for. So I have 4 and 11. Now, what I find is of the 3 guys inside of there, I got one really good guy, I got an imaginary guy, and then I got a leftover trash guy. So here's the way you're always going to pop these out in order. In math people, do we care? We do. The order in which you put whole numbers, i's, and radicals is like this. Whole number part goes first, imaginary unit goes second, leftover crap radical goes third. Okay. Let's practice that again. I'm not scared. Like, I understand now that this is no big deal. I just have to use a different number system. So how am I going to divvy up my -300 in the middle? What's the first thing I put? -1. Thank you. And then I got to just worry about 300 like normal. I'm out of imaginaries now. I'm just thinking normal. What two numbers make 300 that I really like? 100 times 3 is perfect. So I have my everything now. Make sure everything inside multiplies to make negative 300. Yeah, okay, we're good. I didn't cheat. So the first one to pop out is going to be the square root of 100, which is 10. The second one to pop out is going to be the imaginary unit, which is I. And the third one is going to be the leftover, the guy that couldn't break out of jail, and he's root 3. And finally, what if I have a root that just isn't workable at all? What if I asked you to do the square root of negative 7? What would I break the inside up into? You can't do anything with 7, right? Therefore, the answer to this is just I root 7. I get this question every year, so I'm going to run interference and ask it and answer it myself right now. Why does the I have to go there? Why can it not go in the back of the radical? And mathematicians, long before I was on this planet, decided that this has to be a thing, because if someone writes the square root of 7i, we start to wonder, is the I supposed to be in the radical? Does someone have an imaginary unit buried inside of another radical? So to alleviate that from ever happening, to prevent it from ever happening, we decided, not me, other people decided that the imaginary unit cannot go after a radical. I apologize on behalf of whoever thinks that they should make that much noise in the halls. So to summarize, the regular number will always go first. The I will always go after the regular number and before the radical. Got it? Assignment 15 is all the normal, regular, real numbers. Assignment 16 is all negative imaginary numbers. Good? As always, that took a lot longer than I think it should have, but now you're all educated up. The rest of the time, 15 minutes today is yours, and then all day tomorrow is obviously yours as well. So I would encourage you to go back and work on that assignment 14 first and slug through that, and then you'll have a whole bunch of time in class tomorrow. Okay.